Been really enjoying flying the mini copter Diablo, but I've had a few problems, most of which are my own making. One of which was we lost the tail on the weekend, and the reason being is this M4 set screw or grub screw, if you're in Europe, was just done up a bit too tightly in this alloy tail pulley wheel here. Basically it stripped the thread and the tail shaft went skidding around inside, losing the tail. Not much damage unfortunately, mostly some broken tail blades. Anyway, no worries with that. We've drilled out and tapped M4. That's with a number 30, 3.3mm pilot drill. New thread down there. But now the next question is the tail rotor shaft bent or not? Looks pretty well straight to me. Get it up against a straight edge. Looks pretty well straight again. Have to keep it parallel with the edge. Can't see a lot of problem there. And then the famous last roll test, which a lot of people swear by. Helps if you haven't got stains on the table, but anyway, give it a roll. Seems to roll pretty okay to me. So is it bent or not? I thought probably not. So anyway, thought we'd get a dial gauge, mount it up in the milling machine and just check. So here's our milling machine that I'm going to mount up the tail rotor shaft in, and here's a dial gauge. Dial gauges come in two sorts, roughly speaking. There's a plunger sorts like this, which is capable of a lot of movement, and this one is a millimeter one. This is a slightly different one down here that I'm going to use. In my mind it's better for testing shafts and things. It's got a little lever on there. And this one is actually, it's got a lot less movement to move, so it can't measure such great run out, but it's great for just dragging over the surface of a shaft. And this one's an Imperial one calibrated in thou, which to my mind is much easier to use than fractions of a millimeter. It's mounted up on a dial gauge stand, and these things are clever. They've got magnetic bases. Just switch the magnet on and the thing is pretty well rock solid. That's me trying to move the thing around there now, under it, and no problems at all, move it around. So, a drill base, a column drill or a mill machine is absolutely perfect for this because we can mount up our dial gauge on there. So we'll stick the tail rotor shaft in the gauge and we'll just check out what the run out is. So here's our dial gauge mounted up with the lever on the end of the shaft. The shaft's mounted up into the milling machine. We'll put some power on, and these electric milling machines are really nice because you can get them to move ever so slow, which will start her up now. There we go. And look at that dial gauge flick around there, absolutely no doubt at all that has got a good bend in it. And we've calibrated to 0 just there, and then if we move it around, it's going up to 1, 2, 3, 4, 5, 6, 7, nearly 8 thou run out, which is pretty darn bent. And in actual fact, if you just mount it up into the pillar drill or the milling machine and spin it round, you can actually see very obviously that's got a good bend in the end. And you can even see where the bend is. The top bits are pretty well straight, but it's had a bit of a whack. Probably where it comes out there, there's a journaling mark there, probably where it's come out through the bearing, I'd say, from the side tailgate case. And so we've got a mighty bend down there. And just for kicks, we've got 8 thou run out on that. We'll put a brand new one in and see what the run out is on that. That's our brand new shaft mounted up without the dial gauge. We'll give that a spin round. Look at that, can't see any movement at all. These are lathed down incidentally, and then they're precision ground down in grinding machines. They're not lathe finished. We'll just put the dial gauge on there now for a check. And there we go, mounted up there now, brand new shaft, no more than 0.2, about 0.15 of a thou run out. Very impressive. You can imagine how much vibration that would have had if we'd have kept the bent one on there spinning around at 10,000 revs per minute. So I think the glass test is useless, the glass rolling test, quite honestly. I think mounting it up in a drill is pretty sensitive, and if you've got a dial gauge like this, that's just got to be the duck's nuts. And just for kicks now, we'll mount up a Chinese tail rotor shaft. Looks pretty good. Looks very straight, but look at that. Still very little run out, but that's about 1.3 of a thou run out on that, as compared to the 0.15 thou of a run out on the German Minicopter one. So there's where your bucks are going, and if you zoom in, you really can't see any variation at all, and it works fine. But there's no doubt at all the Minicopter one is head and shoulders above that one as far as tolerances are concerned.